Okay, so we're going to start our next unit, which is linear and quadratic inequalities, and take a look at section 9.1, linear inequalities in two variables. So we are going to take a look at linear equalities in two variables that could look like one of the following four, where you have a less than symbol, less than and equal to, greater than symbol, greater than and equal to, where A, B, and C are real numbers. Now, just to remind you a little bit of some past math that you would know. From last year, if you have an equation in this form, it's general form. If it's in the form of y equals mx plus b, it's y-intercept form, or slope-intercept. Okay, and I don't think you covered this last year, but if you have an equation in the form of ax plus by equals c, this is called standard form. And we'll be looking at these two. Okay? Now, just to go over what an inequality, or linear equalities in two variables is. Okay, so an inequality in two variables, x and y, describes a region in the Cartesian plane. Okay, so we're talking about an area. Its solution would be the set of points that satisfies the linear inequality. Okay, we can call it a solution set or a solution region. So the line related to the linear inequality of y equals mx plus b, or boundary, divides the Cartesian plane into two solution regions. So the equality form of the inequality, okay, so if I take an inequality and write it as an equality, it's the equality part that defines the boundary, which is the line that will separate what's above the line from what's below the line. For one of the solution regions, if y is greater than mx plus b, and it's true, then you would have the region which is above the line. Okay, so this is the blue region on the graph. If the other solution region, y is less than or mx plus b, is true, then we would get what's below the line, which is the pink region on the graph. Okay, so provided that y is on the left-hand side of the inequality, if the inequality is greater than, it means above the region. If it's less than, it means, above the line, and if it's less than, it means below the line. Okay, and the solution to a linear inequality in two variables is a solution region that may or may not include the line. Okay, so if it's a dotted line like this one, then the line is not part of the solution. If it was a solid line, then the line would be part of our solution. Now we're going to take a look at two methods to graph inequalities in two variables. The first one is using the slope-intercept. Step 1 asks you to graph the corresponding equation. Okay, so that would mean you want to graph y is equal to mx plus b. You want to solve the inequality for y. Simply means that you want to isolate for y and consider whatever the inequality is. It will tell you whether you're going to graph above or below the line. Once you've written it in this form, then if it reads greater than, you shade the region above the line. If it reads less than, you shade the region below the line. Now remember, this is only true if y is to the left of the inequality. So y must be to the left of the inequality. Okay, so an example would be something like y is less than mx plus b, so to the left. Now, if you have, if the inequality is less than equal to or greater than equal to, it means that you want to graph a solid line in the shaded region. Okay, it's the equal sign that tells you want to graph a solid line. If it just reads less than and equal to, or sorry, less than and greater than, it means you want to graph a dotted line in the shaded region. So because it doesn't read equal to, you're going to graph a dotted line. Our second method is to use the x and y intercepts method. Okay, and what this means is that you're going to have your equation in standard form. Oops, hang on. Standard form. Okay, you start off with the same step that you would for our method 1, but this time you are going to be looking for your x and y intercepts. Okay, once you have your line graphed, then you are going to select a test point from each region to determine which contains the solution. And then whichever one is in the solution region, you are going to plot the point there, and then you will shade in the half plane in which this point is located. Okay? Alright, in my next video I will go and go through example 1 with you. Okay, so let's take a look at example number 1. You are asked to graph 2x plus 3y is less than or equal to 6, and then determine if the point -2 and 4 is part of the solution. So I want to start with example number 1, method 2, where we're looking for x and y intercepts. Now the first step of solving is to graph the corresponding equation. So our corresponding equation for step 1 is 2x plus 3y is equal to 6. Okay? And we want to use x and y intercepts, so our x-intercept occurs when y is 0, so we're going to plug in y is 0. That leaves us with 2x equals 6, so x is equal to 3. And then our y-intercept, which is when x is 0, so we plug in 0 for x. That leaves us with 3y equals 6, and y is equal to 2. Now we can go straight away to graph this, okay, because we have enough information. What you want to take into consideration, though, is to take a look at your inequality. Notice it has an equal sign on it. So when you graph this line, you want to graph it as a solid line. Okay, so here it is graphed. So your y-intercept, sorry, is at 0 and 2, and your x-intercept is at 3 and 0. Because we want a solid line, graph a solid line through here, and remember to label your line. And notice I'm labeling it with the equality, right? Not the inequality, because the line is defined by the equality. Okay, so now we're ready to do step number 2. And step number 2 asks you to select a test point from each region. Okay, so what that means is we want to select a point which is above the line and a point which is below the line. Now you want to pick points that are easy to work with. Okay, so you don't want to pick something with large numbers. All right, so let's start with a test point which is above the line. Okay, and I'm going to pick 0, 4. All right, and I'm picking it because there's a 0 in there and it's nice to work with 0. So one of my test points is going to be 0 and 4. I'm going to plug that into our inequality, and our inequality is 2x plus 3y is less than or equal to 6. So I'm going to put in 0 for x and 4 for y. I'm going to simplify, so 2 times 0 is 0, 3 times 4 is 12, and I get 12 is less than or equal to 6. Well, is that true? I mean, is 12 less than 6? No, it's not. Is 12 equal to 6? No, it's not. So this is false. So it doesn't equal. So this is false. So what that means is that our region is not going to be above the line. Okay, so let's try it out with a point below the line. I'm going to pick 0, 0 because that's a nice test point. So let's go with 0 and 0. Plug in 0 for x and 0 for y. And I get that 0 is less than and equal to 6. All right, well, 0 is less than 6, so that's true. 0 is not equal to 6, but even though that's false, because part of our inequality is true, the 0 is less than 6 part is true, we say that this is true. Okay, and that means that our region will be shaded below the line, and that is our step 3. Okay, where you are asked to plot the point on the graph and then shade in the half plane where this point is located. So we want to shade the region which includes 0, 0. Okay, so we go to our graph, and our point 0, 0 is right here. That means I want to shade below the line. And there is my graph fully graphed. Okay? All right. Now, remember, the reason why we have a solid line here is because our inequality reads less than and equal to, and the equal to on that inequality will give us a solid line. All right, so let's take a look at method 1, okay, graphing by using y equals mx plus b. Step 1 and step 2 essentially are the same for both methods. You want to graph the corresponding equation. So our corresponding equation is 2x plus 3y equals 6. And because we want to graph using y equals mx plus b, that means I want to isolate for y. So my negative 2 will, or sorry, my 2x will go to the right. It becomes negative 2x. So I have negative 2x plus 6. Divide everything through by 3. And I get that y is equal to negative 2 over 3x plus 2. Okay, so what does that mean? Well, it means that I have a slope which is negative 2 over 3, and I have a y-intercept which is at 2. So we can use this information to graph our line. So here's our y-intercept. Okay, we already know where that is from our first equation, but we also know that we have it because b is equal to 2. Now a slope of negative 2 over 3 means that you want to go down 2 units and to the right 3. So let's go down 2 units and to the right 3. That brings us to our x-intercept. And we can repeat that again. So down 2 to the right 3, and we have another point here. And you can also go up 2 units and to the left 3, because that will still give us a negative slope, right? So up 2 to the left 3, we get a point here. Up 2 to the left 3, we have a point here. And once again, because our inequality is less than or equal to, and we have an equal to sign on there, we can graph in a solid line. Okay, so step 2, on method 1 says to solve the inequality for y. Now we've already solved our equality for y, so solving our inequality for y would go through the same steps, and I would do the same I would do them both at the same time, but just for illustrating as an example, I'm going to do them separately. So we got 2x plus 3y is less than or equal to 6, so isolate for y. Okay, divide by 3. And y is less than or equal to negative 2 over 3 x plus 2. Okay, well that less than or equal to gives us information, right? So that's our step 3. Okay, so step 3 says that if we have greater than, we want to shade the region above the line. If we have less than, we want to shade the region below. All right, now our inequality is less than or equal to, so it means to graph below the line and use a solid line. Okay, and so we would get exactly the same graph. And if you are going to use method 1, you will label your line y equals negative 2 over 3x plus 3, 2. Okay, so our last step is to, or the last question we're asked to do is to determine if negative 2, 4 is part of the solution. So let's start with our inequality, which is 2x plus 3y is less than or equal to 6. Substitute in negative 2 for x and 4 for y. And that gives us negative 4 plus 12 is less than or equal to 6. And we get 8 is less than or equal to 6. And that's not true, right? Because 8 is not less than 6 and 8 is not equal to 6, so it's not true. And so therefore the point negative 2 and 4 is not part of the solution. Okay? Now, one thing that I do want to go over, and maybe I will do that, I'll do it down here, I guess. Any point which is on the line is part of the solution. Okay, when it reads less than or equal to, then any point on our line is also part of the solution. So let's check using our y-intercept, because we know that's a point on the line. So let's check with 0 and 2. Plug that into our inequality and see if it's true. So we're going to go 2 times 0 plus 3 times 2 is less than or equal to 6. So we get 6 is less than or equal to 6. Now, even though 6 is not less than 6, 6 is equal to 6. So we say this is true. And so any point on the line is part of the solution. Okay, so we will conclude part, or example number 1 here. Okay, so we're going to start example number 2, which is to graph a linear inequality of the form ax plus by is greater than c. Notice our inequality just reads greater than, not equal to, so that's going to change how our graph looks. You might want to try this on your own and pause your video and come back to it once you have completed it and see how I solve it. Okay, so we're going to graph 10x minus 5y is greater than 0. This is in general form. And I'm going to use method number 1, which is to graph using y equals mx plus b. And I'm going to combine steps 1 and 2. I can get the same information regardless of whether I change my inequality to an equality or not. So I'm going to get 10x minus 5y is greater than 0. I want to isolate for y. And so I get negative 5y is greater than negative 10. And I notice that I'm going to be dividing both sides of my inequality by a negative number, and in this case, negative 5. So if you go to the right, and just remember something that you learned from grade 9, to reverse the inequality sign when dividing or multiplying both sides of an inequality by a negative. And that's what we're doing. So our greater than sign is now going to become less than, and so what we are left with is that y is less than, oh, this should be x, shouldn't it? 2x. Okay, so this is in the form of y equals mx plus 2b. Notice we don't have a value for b, so I'm just going to put a 0 in here. I don't expect you to do that, but just for the purpose of our lesson, I'm going to do that. So the information that I get is that my slope is 2, or if you like, 2 over 1, and my y-intercept is at 0. So we can graph our line right now, and because we don't have an equal to on this inequality sign here, we're going to graph it as a dotted line. Okay, so let's start with our y-intercept, which is at 0. we have a slope of 2 over 1, which means we're going to go up 2 and to the right 2, 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 and then down 2 and to the left, down 2 and to the left 1, down 2 and to the left 1, and we graph with a dotted line. Now, remember when you label this line, though, we don't use the inequality, we use the equality. So y equals 2x. Now we want to discuss what our less than sign means. Okay, so notice our y is on the left-hand side of our inequality. So our less than sign means to graph below the line. And use a dotted line. Okay, now we are also asked to verify. Oh, right. Okay, so we should really graph that, shouldn't we? All right, so it means below the line. So that means I want to graph everything below our line. Now we want to test to see if that is for sure, okay, that's really what our region is. And so we want to pick a test point in our shaded region. Now I'm going to pick one, like I say from before, that's kind of easy to use, right? So I probably want to pick one that has 0 in it. So I'm going to pick this point right here. It's in our shaded region, and it's at 0 and -2. This is my test point. Okay, so I'm going to plug that into my original inequality. So 10x minus 5y is greater than 0. And in place of x, I'm going to put 0. And in place of y, I'm going to put -2. And I get 0, and -5 times -2 is 10. So I get 0 plus 10, which is just 10. Is 10 greater than 0? Yes, it is. That is true. So our shaded region is correct. Okay, so that ends our discussion on example number 2. Okay, so we are going to do example number 3, which is to write an inequality given its graph. All right, so our graph is here on the right. And probably the easiest way to come up with an equation for this line is to use y equals mx plus b. So I'll be interested in the y-intercept and the slope. So my y-intercept is at 0 and 1. Okay, so y-intercept is at 0 and 1, which means in y equals mx plus b, b is equal to 1. And my slope is going to be 2, and I'll show you how we work that out. So you want to go along your line, and you want to find some points that actually go through the grid line. Okay, so there's a few. You can go use this one, and you can use this one. All right, I'm going to use our first one here. And so I am going to go up 2, so plus 2. And I am going to go to the right 1, so plus 1, which means that my slope, m, is equal to rise over run, which in this case is 2 over 1, which is 2. Okay, and so I know that my slope is 2, so that means m is equal to 2. Okay, now the other thing that I want to take into consideration, so I'll just call this part 1 and this part 2, I want to consider my inequality. Now I notice that my shading is above my line. So the shading, the region, the solution region is above the line. And the other thing that I notice is that my line is a dotted line. Okay, and the line is a dotted line. So now I'm ready to write my equation. I'm going to start with y equals mx plus b. Okay, I know that m is 2, so in place of m I'm going to put 2. And I know that b is 1, so I'm going to put in 1, so I get 2x plus 1. And because my solution region is above the line and the line is a dotted line, my inequality is going to be greater than. And so I'm going to put greater than in here. And so I have an equation or an inequality of this graph in the form of y equals mx plus b. Now I can also put that in the form of ax plus by equals c. Okay, so I'm going to start with my y equals mx plus b form. And I want to move my 2x over to the left, right? Because I can leave c on this side, which will be 1. So that's going to give me negative 2x plus y is greater than 1. But in standard form, a is always positive. Okay? And so we are going to, and it's always a whole number. Okay? So I'm going to put, well, actually a whole natural number. So I'm going to put, I have to make this negative 2 a positive 2, right? So what I'm going to do then is to multiply everything through by negative 1, because that's going to change the value of all of my terms, okay, the signs of all of my terms. And remember that because I'm multiplying by a negative number, both sides of an inequality, I have to reverse the inequality. Okay, so negative 1 times negative 2x is 2x. Negative 1 times y is negative y. Switch my inequality from greater than to less than. And negative 1 times 1 is negative 1. And so here is my equation in standard form. Okay, so this concludes example number 3. Okay, so we're going to do an application problem. You are asked to write and solve an inequality. A sports equipment manufacturer makes footballs and soccer balls. One football requires 4 minutes on the cutting machine, while one soccer ball requires 3 minutes on the machine. Determine an inequality that would represent this situation. So that's one thing you've been asked to do. Draw a graph of the inequality to show the number of each type of ball that could be made in 30 minutes or less. So that's another thing you've been asked to do. And then 3, select one possible combination and check it in the original inequality. So we're going to start by coming up with an inequality that would represent the situation. Because we're given some specific information, like we want to know the number of footballs and soccer balls that we can cut in 30 minutes or less, it looks like our inequality has to address the issue of time. Okay? We know that one football requires 4 minutes to cut and one soccer ball requires 3 minutes to cut. We want to know the number of each type. Okay, so that's something else that's important. So how are we going to figure out how many footballs we could cut and how many soccer balls we could cut in 30 minutes or less? So our let statement is going to reflect the number of each type of ball, because we already know how long it takes to cut each, but we just don't know how many we have. So we're going to let x be the number of footballs cut, and we're going to let y be the number of soccer balls cut. Okay, so what we want to come up with now is a single expression that would help us calculate the number of footballs that we could cut in 4 minutes and the number of soccer balls that we could cut in 3 minutes. So how long it would take to cut X number of footballs would be 4x, right? Okay, so the number of footballs times the amount of time it takes to cut one. And to that we're going to add the number of soccer balls that we could cut, okay? Knowing that each one of them takes 3 minutes. So that would be 3 times y. So the number of soccer balls that we would cut times the time. Now 30 minutes or less means that it could be equal to 30 minutes or less than 30 minutes. So the inequality that's going to represent that is less than and equal to, and so we say less than equal to 30. And so we have our inequality. So the next thing we want to do then is to draw our graph. Now I'm going to use method number 2, which means I want to find my x and y intercepts. If you would like to use the slope-intercept method, then you can. So I'm going to start by finding my x-intercept. I'm going to use the equality form of my equation. I'm going to substitute in 0 for y. I get that 4x equals 30, divide by 4, and I get that x is equal to 7.5. So my x-intercept is 7.5. My y-intercept is when x is equal to 0, so I'm going to go 4 times 0 plus 3y equals 30. And so 3y equals 30, so y is equal to 10. And then I'm going to graph this. Okay, so I said y is number of soccer balls, so number of soccer balls goes along the y-axis. And the number of footballs goes along the x-axis. And I know that my y-intercept is 10, so I'm going to make this 5 and this 10. So I'm going to graph a point at 10. Okay, and I know that my x-intercept is at 7.5, so let's make this 10. So 7.5 is around here. Okay, so I will graph that. Oops, sorry, 7.5 and 0. And then I have to draw my line. So I go back up here and I look at my inequality and it says equal to, so that means use a solid line. So I'm going to join my 2 points with a solid line. And I need to shade my region. So I need a test point, okay? So I'm going to pick 0, 0, that's a good test point. So I'm going to test with 0, 0. And so I'm going to go 4 times 0 plus 3 times 0 is less than or equal to 30. So 0 is less than or equal to 30. And that's true, right? Because 0 is less than 30. So that means shade below the line. Okay, and so I get this. Now you don't want to go outside of your x and y axis because negative numbers are meaningless in this example. Okay, and so we would get this as our graph. Okay, so that brings us to the third item on our list, which is to select one possible combination and check it in the original inequality. Okay, so step number 3. So let's pick a combination. That could be any point in our solution region. Okay, any point that you want. So I'm going to pick 2 and 5. You can pick any other point, okay, but I will choose this. There's no reason why, just that it's in that region. And so one possible, well actually why don't I just work it out first. Okay, so we're going to go 4 times 2 plus 5, sorry, 3 times 5 is less than or equal to 30, so I get 8 plus 15 less than or equal to 30, and so I get 23 is less than or equal to 30. So is that true? Well, 23 is less than 30, so that's true. 23 is not less than 30, that's not true, but that's okay because 23 is less than 30, so this is true. And so one possible combination is, and what, 2, 5, and what does that mean? Okay, well, we know that our x-coordinate is number of footballs and our y-coordinate is number of soccer balls, so what it means is that we can make cut 2 footballs and 5 soccer balls in less than 30 minutes. Okay, so that answers our question, okay? And I want to now take a look at how to do this on your graphing calculator, okay? But I think what I'll do is save that for a second video or a next video. Now we're going to use our graphing calculators to graph our inequality. So if we have 4x plus 3y is less than or equal to 30, what we need to do, because we are going to put that into our y equals screen, we need to isolate for y. So I'm going to move the 4x over to the right. It becomes negative. Divide everything through by 3. So you get negative 4 over 3x plus, and then 30 divided by 3 is 10. Okay, and because we've already manually graphed this, you can see that your x and y max will be at 10. So for our window settings, we will have a x min at 0 and x max at 10, a y min at 0, and a y max at 10. And I've already entered the equation into the calculator, and if you go to your window settings, you can see that I've set them in already, so 0 and 10 and 0 and 10. Now going back to the y equals screen, if you move your cursor to the far left, you have different options for graphing. So if you want to do an inequality, what you're looking for, there are 2 settings. Okay, one of them looks like this. Okay, this means that when your calculator shades, it will shade below the line. And if it looks like this, it will shade above the line. Okay, so we're going to go ahead and choose our below the line. We have to hit enter several times until we get there. So this is above, and this is below, and then we will graph. Alright, and this is what you get on your graph. So you have graphed the inequality 4x plus 3y is less than or equal to 30. What we're going to do now is we're going to graph our inequality on our graphing calculator. And because we need to enter our inequality into the y equals screen, we will need to isolate for y. So I'm going to move my 4x over to the right. It becomes negative 4x. And then I'm going to divide everything through by 3, so I get negative 4 over 3x plus, and then 30 divided by 3 is 10. We will need to set our window settings. So my x min, I put in at 0, my x max at 10, my y min at 0, and my y max at 10. Okay, and I've already put that into my calculator. So I'm ready to put my inequality in. The first thing I need to do is to pick the type. If you notice at the top of your screen it says graph function, and right now it reads y equals. Well, we need it to read y is less than and equal to, according to the inequality that we want to graph on our calculator. So you want to press F3 for type, and then you want to press F6 for more options. And if you take a look, you've got y is greater than, y is less than, y is greater than and equal to, and y is less than and equal to. So we're going to choose y is less than and equal to. And you can see now that it reads that at the top of your screen. And then we're going to enter in our inequality. Okay, so we're going to go bracket negative 4 divided by 3, bracket, and then x plus 10. And then execute, and then you can draw. And there you go. That's what you get when you graph your inequality on your graphing calculator.